All right. Hey, folks, welcome. Thanks for joining my session. As I was introduced, my name is Andy Grabner. I do work for Dynatrace during the day. At night or outside of that, I'm also the DevRel for the open source project Captain. It's a CNCF project. If you want to know more about Captain or follow up later on, you can see all the links here. It would be great if you want to follow us on Twitter, fork, or clone us on Git. And we also have a Slack channel. Now, also just a little reminder, if you also want to know more about what else we're doing, the project is heavily supported by Dynatrace, but you will see all the other things that we're doing. But feel free to also join at our booth that we have set up for you at this conference. So a guide to event-driven SRE-inspired DevOps. I know this is a lot of buzzwords that we put into this title, but let me assure you, I'm not doing some buzzword or bullshit bingo here today with you. I really want to show you how we believe we can make the DevOps and the delivery and the operations world easier. And this is where Captain comes in. Okay, let me get started. In case you've never heard about Captain, what is Captain? Well, Captain is the following. For you, what it means, whoever you are, you might be a developer, you might be a DevOps, you might be an SRE, you basically pick your use case. Captain supports different use cases around progressive delivery, SRE-inspired quality gates, and auto remediation. Then you bring your configuration where you specify your processes, your SLIs and SLOs and your runbooks, and you then connect your tools. We're not dedicating any tools. We are connecting with your tools. And then Captain automates the process that you have declaratively explained. We're using Git, where we store and version control all the assets. We're using SLO, service level objectives, at the center. I will cover this in a little bit more, what this really means. And Captain is based on standards. That means all the tools we're integrating with, we're communicating with them through a standard protocol, which means you can easily also replace and bring in your own tools what you want. Everything is standard based, nothing is proprietary. So this is Captain. Why we built Captain? Well, if you look at the latest State of DevOps report, which came out last week, a lot of organizations are now building their next internal delivery platforms. And with Captain, we are addressing a couple of the problems we have seen that hold back people from faster adoption. As you can see here, there's a lot of talk about time wasted in maintaining pipelines, in manual tasks, or in manual remediation. And I want to start now actually by going into each individual area and then show you how we address these things with Captain. The first thing is we believe, and as I was asked in the beginning, what about this strange thing when I talk about monolithic pipelines? So what we see, people are wasting a lot of time in making sure their existing monolithic pipelines work in their new environment. So what does this mean? If you look at this pipeline here, it's a screenshot of one of our Jenkins pipelines we have internally. Then whether you like say Jenkins or any other tools, that's up to you. But the problem with many of these tools are, and I'm not generalizing here, not saying that every tool has this problem, but in most delivery tools these days, you have mixed information about the process and the tooling, and in where's your target environment and how do you deploy. So it's a mixed information, like a big monolith where everything is kind of cobbled together. And there's no clear separation of concerns between process definition and the tools that actually do the work. This is already one issue. The next issue is when we started our journey from building and deploying monoliths with our, back then it was initially quick build, then we went to Jenkins. Obviously, we chose tools for delivery that we knew. And Jenkins is a great tool. I'm not bashing on it. So we started with Jenkins pipelines for our microservices. Then more services were onboarded. They took these Jenkins pipelines, slightly modified them, adding some things that were specific to the services. And this then continued until we ended up with many different pipelines that were all kind of adjusted a little bit for their needs. The problem is if now something breaks, it's very hard to figure out why does it break, who brought in this plugin, who brought in this stage, why is this not parameterized, where does this value come from? And this is why I think this traditional approach is not quite what we need, or we need to think differently. So that's why with Captain, we want to redefine, or we want to give you a new approach to delivery. It's an event-driven approach. And event-driven is also nothing new, because basically what I'm explaining to you now is the same thing that we've been doing when breaking monolithic application architectures into smaller pieces, whether you want to call them microservice architectures or just service oriented, I don't care what you call it. But essentially, we want to do the same thing with delivery. So on the left side, you see a classical process of delivery: build, prepare, deploy, test. You may add some notifications and some rollback capabilities in there at some stage. But often these are, as I said earlier, hard-coded to the individual tools that are doing the thing. So what we said, why not just break up these dependencies? Why not think about this as, on the left side, you have a process, have a clear process that you can orchestrate and execute. And on the right side, you have tools that provide certain capabilities that can do a certain thing once you're executing a process. This is just like breaking the monolith into microservices. You're thinking about what are your business processes you want to solve and what services do you need to solve it. And the connection between them is eventing, just as in your microservice architectures. And to give an example here, if we have a process orchestrator that says, I need something in my step right now to deploy, then the process orchestrator would send an event that says, who can deploy this particular artifact, container number 1, in dev with a blue-green deployment strategy. And now you can have one or multiple services that listen and subscribe to these events and say, yes, I can do this. I have these capabilities and I want to do it. So this tool then says, yes, I can do it. Let me do it. Once it's done, sends back, it's finished. And then the process orchestrator is continuing the process. So in the end, what we're doing is we need to figure out what is the process and what is the tooling, and we connect it through events. And this is exactly what influenced the architecture of Captain and why we built Captain the way we built it. Captain itself is a container-based solution. It's a service-based solution where we have one of the core components is a control plane. So you install Captain on Kubernetes. You get a control plane that manages the processes and the workflows. Then we have an eventing engine. We're using Nets right now, which is also another open source project. Now, on top of that, when you start using Captain, you have one team that needs to define the processes that they want Captain to orchestrate. We support 2 major processes. One is for delivery. We call it shipyard, where you specify which stages you have in your delivery pipeline, what type of testing should happen, and what type of deployment should happen, and what are your SLIs and SLOs. You can see here dev, staging, prod, direct deployment, functional testing, SLOs for dev. The other type of process is a remediation process for production. Here we talk about remediation files or remediation processes. So here you can specify for which particular problem, which actions should be executed. So you define the process on one side. On the other end, you have another team that defines, okay, which tools do we want to use? We don't dictate the tools, but you bring the tools to Captain, you connect them. And we call this a uniform. So for every tool you want to use, whether this is Helm for deployment or Jenkins for deployment or Spinnaker, whether this is JMeter or Neotis for testing, whether this is Prometheus or Dynatrace for monitoring, you basically plug in your tools by letting them listen to these events that Captain will send out as it is executing the workflow. Now, how does this look like? In the end, you have a developer for the delivery workflow now, as an example, that says, I have a new artifact and I want you, Captain, to now execute your process by sending the events, and then the right tools that have been enabled by the DevOps team, for instance, will then handle these events, and with this, push the artifact through the process, right? So it's a separation between concerns, process, and tool definition. Everything is connected through events. The great thing is, with this, you can easily change your process. You can, for instance, add a stage, remove a stage, change from one deployment strategy to another without having to think about which tools do I need to do this. And then you can also change the tools completely separated. I think that's a nice approach that we're taking here. Now I want to give you the first demo. What I've prepared is a 3-stage delivery process with Captain, and I have version number 3 of my build already deployed. And what I will demo is I will basically kick off a deployment of build number 4. Captain will then take it and push it through the workflow. So it will deploy it and run some tests. Then a key component to Captain is evaluate. We are pulling in SLOs to act as quality gates. Depending on that result, then automatically decide whether we can promote it to the next stage. And then the next stage goes on, deploy test, evaluate, Then promotion here, you can specify in Captain whether you want to automatically promote or whether you want to have somebody that actually needs to approve the promotion. For instance, in production, you may not want to automatically promote everything, but you want a release manager to then say, yes, check the box. Then in production, I do blue-green deployments. That's one of the deployment models we support. With the blue-green deployment happens, Captain evaluates again. If it's a bad evaluation, then it can toggle back to the previous version and then reevaluate. And this is kind of the way the delivery works, right? We're increasing speed and quality through automation. For completeness, the second workflow, which I'll show you later, is also that in case you have something running in production and a problem comes in, then Captain can orchestrate the remediation process or the remediation workflow, which means problem comes in, Captain maps it to your runbook, your workflow, which will then trigger an action. After the action is executed, like scaling up, an evaluation will be done. If it's not successful, that means if the system is not back to a healthy state, we'll trigger the next action, reevaluate until it hopefully everything is good. All right, but let me now go into the first demo with progressive delivery. So what I have here, I have Captain installed on a Kubernetes cluster. In my case, it is EKS. And I have a couple of projects here, but the one that I want to show you is my Captain 07 project, where I already have, as you can see here, my dev, staging, and prod environment. Now, let me quickly, build number 3 is deployed here. Let me quickly kick off build number 4, because this will take a couple of minutes. So what I'm saying here, through the API, I basically say, Captain, send event new artifact. Hey, Captain, I have a new artifact for you for this Captain project, for this service, and here is my new image and maybe my tag. And you can also do other things, replica count or whatever else you have. Now, as we're here, you can actually see that I've also opened up the shipyard file. So this is really everything that I had to do in order to set up my Captain project for multi-stage delivery. I have this YAML, I specify dev, staging, and prod, what type of deployment strategy I want in each stage, what type of test strategy, and what type of approval strategy. And that's it. So when I do initially a Captain create project, that's all I had to do, and then it automatically created this for me. So let me actually have a look at this. In dev, build number 3 is deployed. I can also automatically open this. Right, build number 3 runs in dev. This is a very simple Node.js-based application that through the Captain process was deployed via Helm. And then in staging, I also have build number 3 probably deployed in staging. That's good. So my app is actually, as you can see here, just telling me what type of, in which environment I am. All of this is monitored in my case with Dynatrace. You could also use Prometheus or any other monitoring tool. But now what Captain is basically doing, it is enforcing my process. How can I see this? I can click on services, and then here I have my one microservice. You could obviously have, in a real application, have multiple microservices, but I'm going to this one here. I can now see I kicked off the process for build number 4 at 12:33. So on the left side, you see all the deployments. You can see I constantly do build 3 and 4 for all of my demos. And on the right side, I can now see how Captain is sending events to enforce my process. It seems build number 4 was already deployed. So that in dev, that means if I go back to my browser tab where we had build 3 earlier, if I refresh now, build number 4 is deployed. And now the process continues. It will execute some tests and so on and so forth. Now let me go, in the sake of time, we'll come back to this later, but let me just show you from the previous build that I did this morning, what will happen. So build number 4, in dev deployed, tests will be executed. Captain will then retrieve SLIs. It will then do an evaluation. And if this is good, then it will go on to the next stage. In my case, staging. It will make a configuration change. It does a deployment. It executes tests. In my case, I've connected JMeter. It will then retrieve SLIs. I have Dynatrace connected. Then it enforces all of my quality gates, meaning it pulls in all the metrics, and then depending on the score, will then say go forward, yes or no, and so on and so forth until it hits production. So this is a quick overview and a quick demo of the delivery use case, right? So very easy. You declare your process. You bring some of your configuration items. Like initially, I had to bring my Helm chart, obviously. I had to bring my JMeter script. So you bring configuration items that your individual tools that you're connecting to are then need. All right. Now, another example, Captain should not be there standalone. Captain should be integrated with your other tools. Patrick, for instance, from Amazon, they're using GitLab CI to build their containers. And once they are pushing up their images to the container registry, then they are kicking off a Captain delivery process that is doing multi-stage delivery of their individual services, enforcing their quality gates and all that stuff that I showed you. So this is just to show you can really integrate Captain in two ways. On the one side, Captain can orchestrate processes and then communicate with your individual tools. But on the other side, you can also trigger Captain from your individual tools because they are already doing a great job, and then you can add in or trigger a Captain workflow. All right. Looking forward to some questions, by the way, later on as well. Just encourage you, if you have questions, either give us them here in the question feature or later on in Discord. So next use case is Captain. While we do delivery end-to-end, a key use case is speeding up deployment validation, because I think a lot of people are wasting a lot of time in deployment validation. What does this mean? If you have built your own delivery pipelines where you do build, deploy, run some tests, and you typically have a phase where somebody manually needs to look into and decide, is this a good build or a bad build? Looking at your functional tests, hey, this one broke, but is this really business relevant? Should we stop it, yes or no? If you look at your performance test results, in case you execute them, then you may need to decide, performance is good, at least from a response time, but now we have 50% more CPU or memory usage. So do we want to push this out, yes or no? And if you're also adding observability and monitoring, Prometheus, Dynatrace to the mix, then you even have more data, and it typically takes even more time to then decide, is this a good or a bad build? And this is why so much time is wasted. So what we want to do to solve this problem, we are bringing an SLI and SLO-based quality approach to the mix. So now, what is this? Let me give you a quick intro into SLIs, SLOs, and SLAs, because this is part of Google's SRE practices. SRE stands for Site Reliability Engineering. So Google has not reinvented the wheel here, but I think they did a great job in educating us on some very principal core concepts. Google talks about SLIs, service level indicators. Essentially, this is a metric like the error rate of login requests, something you can measure in your application from your services that you deploy. Then you have an SLO. An SLO is, what do you expect a certain metric to be for you to consider it successful? So for instance, the login error rate must be less than 2% over a 30-day period. So if you monitor this and you have a lower percentage than 2% of error rate, then you may consider this is great, right? So you have some objectives, some goals for your system. And now the question is, and some of you may ask, okay, well, this is the same as SLAs. SLAs are service level agreements. And basically what they say, they are like SLOs, but SLAs are what happens if we're not meeting our SLOs. Typically, you may have a legal binding agreement where you with a third-party vendor or with your end user. So what happens if our system is not behaving as expected? So nothing completely new. Google has been talking about this for years. If this is new for you, then really definitely check out some of the content. To highlight it, SLIs drive SLOs, which inform SLAs. Metrics against objectives tell us if we're messing up something where we have a legal binding. Now, the cool thing about this is that a lot of organizations, and hopefully yours as well, you have thought about what are your SLOs, and then you can use your monitoring tools in production to figure out how our response time, failure rate, throughput, how are we doing for every individual service. And then you can use this for monitoring, for reporting, for alerting. And if you have already sat down and if you have these SLOs, then I suggest, well, then use the same concept, but already in your pipeline. So this is what Captain does. So Captain uses the same concept and same terminology so that we actually bridge the gap between operations and dev. So we use the same things by every time you deploy a new service through CD and you run some tests, then Captain can automatically pull out these key SLIs for you and compare them for you against your objectives. Now, additionally, what we've built into Captain These objectives can not only be hard-coded values like 100 milliseconds or 2% failure rate, you can also have Captain compare your metrics with the previous builds. So you can also detect regressions. Technically, how this works, we call the feature Captain quality gates. So we are connecting to all of your monitoring tools again through the event-driven model. So you can plug in any type of monitoring tool. Right now we support Prometheus, Dynatrace, Neoload. Weaveworks is in the talk that's been built by the community right now. But you can plug in your own tool by integrating it with Captain. Now, the way this works, you have to specify a so-called SLI YAML file. So you need to say what type of metrics do you want with a logical name, like in this case, error rate, and next to it, information for the actual tool that delivers that metric on how to query it. This could be a PromQL for Prometheus. In this case, this is a Dynatrace query. And then you specify your SLOs. So this is another file where you say, here is my criteria for every single metric. And then what is your total acceptance? Because Captain will look at all of those and calculate a total score. So that means what you can do is you can say, Captain, start the evaluation for a certain time period. And then here are my SLIs and my SLOs. And then Captain basically reaches out to these tools by sending an event. They report back the metrics for that time frame for that system. Captain then compares them against your SLOs and gives every metric a grade or a point system. And then we calculate a total score and we normalize this with a score between 0 and 100%. Very simple. All right, let me quickly show you also the demo. I'll go into details on what I've showed you. For the Dynatrace integration, we actually made this a little easier. You can still write your YAML files, but we also provided an option where our users can just create a dashboard and put all the metrics on there. And then Captain will basically analyze the data on this dashboard every time you run an evaluation and then calculate the score. So that means if I go quickly back to my demo, right, build number 4, let's have a look at how far build number 4 went from earlier. SLIs are currently retrieved. That's great. So let's actually go back to build number 3 maybe. Here we already have a result, right? So here you can see all these results for every single metric that was pulled in. Here is the dashboard behind the scenes that basically Captain automated for me. So I think the great thing about it is instead of me having to look at my dashboard, whatever dashboard it is, Captain is doing it for me. It's pulling the data, is comparing it. And what you can also see here is the overall score on the top. We also have some historical data that we can show you, right? We show you charts and trends of every single metric of the score overall. We show you all the details here about every metric, what the value was, how it was against what it was compared to. And the great thing is you can also integrate this with any of your existing tooling. So I have a Jenkins pipeline here. And if you're using Jenkins already for, let's say, for build and deploy and for test, then you can just say, or maybe GitLab or something else, then you can just trigger a Captain quality gate evaluation just from your existing pipeline. So what I'm doing here is I'm saying, please, Captain, this is the project that I have on Captain where I specified all of my configuration files, my SLIs and SLOs, and please now do an evaluation for this particular time frame. This could be the time frame of your test execution. And the cool thing about this is, remember, Captain is orchestrating processes, but it doesn't have to be necessarily a complete end-to-end delivery process. It can also just be this particular piece, which is the quality gate. Now, in this case, this will run a couple of seconds. And once this is done, let's see how am I doing today. In the morning, I had a warning. Now I'm back to green. That's awesome. But let me just show you. So Jenkins was making a REST call, and then basically I also get a link in Jenkins to my bridge. So now this is, as you can see here, a different Captain project. It's called the Quality Gate project. And this Quality Gate project really only has a process defined that starts with, in this case, Jenkins build number 115, wanted it to evaluate a quality gate, and then this was the quality gate evaluation. Here I see the visuals, but I also got all the information back into the system where initially I called it. So hopefully this made sense. Give you a more example. Jenkins is one example to integrate it with, but it can also be integrated into GitLab, like Christian. He's doing this where in GitLab, they're using GitLab for deploy, for tests, and in the verify stage, they simply trigger Captain for the evaluation. Speeds up their pipeline tremendously. All right, last section before we go into Q&A. This is about speeding up time in troubleshooting and remediation. So we want to, again, save operations time by using an SRE-driven remediation workflow. Remember, Captain is orchestrating processes. I was focusing earlier on the delivery process, and in the last example, just on the quality gate process. Now I'm focusing on a process that Captain can orchestrate for handling problems in production. So that means if you have a monitoring tool or an alerting tool that alerts you on a problem, you can send it to Captain, and then in Captain, you can specify a remediation workflow. Similar to what I showed you earlier with the shipyard, with the different stages and the actions, here you specify which actions should be executed or triggered by Captain in case a certain problem comes in. In this case, Captain will execute the first action, which means Captain sends an event, and then your action provider can then take it, like scaling up. Important is Captain always evaluates by looking at your SLOs again to see, is the system back to a healthy state? If not, executes the next action, evaluates again. If everything good, then great. If not, it can escalate. Now, while this is great, but I'm sure a lot of you that are in ops probably don't like to try this out in operations the first time. I agree with you. So I think what you want to do is you want to integrate this with chaos engineering. This is why I love chaos engineering so much. With chaos engineering in a test environment, you can first of all validate if your monitoring and alerting works correctly. And then you can really do test-driven operations, which means you can start writing and testing your remediation scripts using Captain, for instance, to really make sure that not only your problems are detected, but that your remediation workflow and your actions really bring the system back to a healthy state in case a problem like this actually happens. And this is what I love about this. All right, so to wrap it up, and hopefully you have a couple of questions later on. What is Captain? Captain allows you to pick a use case that you want to automate. You bring your configuration to support that use case or that use case needs, and you connect the tools that you want. I've shown you Helm, but you can also use Argo Spinnaker for deployment. You can use any monitoring tool. You can connect it, and then Captain automates that for you. The reason why we're doing this is because we want to help you to transform in the way your organization needs you to transform without having all the problems that come with it. If you want to get started, we have a tutorials.captain.sh page where you can get all the tutorials. And obviously, there is many more things that you can find on our GitHub page, on our website. Yeah, I think this was my message to you, to show you that there is a new approach to delivering operations, event-driven, SRE-inspired with the SLIs and SLOs. And now I would be very happy to answer a couple of questions if you have them.